guys. Okay, so we are going to get started with today's lesson. So the first part is going to be finding the distance between 2 points on a coordinate plane. And then the second portion is going to be using Pythagorean theorem to find distance in the real world. So that's like word problems. So if you could please update your table of contents. So this whole thing is called Pythagorean Application because we're applying the Pythagorean theorem. And so that's going to take place between pages 63 to 65. And then more specifically, the distance on a coordinate plane is going to be on page 63. And then the word problems, it might only take 1 page, but I put 2 anyway. So it might be 64 to 65 or just 64. And then if you could please turn to your page 63 and title it, we are going to get started with the distance on a coordinate plane. So I know it's going to be a little bit, different because we don't have a, gosh, I wish I could speak, a grid. Oh, there we go. That was not difficult. But we're just going to have to try our best. Okay, so the first thing that we're going to do is we're going to draw a coordinate plane So if you understand the Pythagorean theorem, then you will understand how to do this pretty easily. So if we're looking for the distance between points on a coordinate plane, so let's do point at 1, 2, 3, 4, 5, -5, +2. So 1, 2, 3, 4, 5, 2. So this is at -5, +2. That's that's point A. And then point B is going to be at -2, -2. And there's B. And we want to find the distance between points A and B. Okay, so we're going to find the distance, this says, and we're going to find the distance between points A and B. And the way that we do that is we're going to first connect points A and B. I don't think I have, I do have a ruler. Yay. I was going to say I don't think I have a ruler, but I do. All right, so I'm going to connect points A and B. Now, I want to know the length of that line segment. So step 1 is to connect A to B, if it's not already connected. If it's already connected, then you don't have to do that one. Step 2, you are going to create a right triangle. So the way that you're going to do that is you can start at either point, and then you want to draw a straight line until you're even with that point. So for example, you can start with either point, A or B, I'm going to start with A. And so I'm going to draw a line down from A to B, like this. Okay? So that was step 2. And then this is still part of step 2. Then connect the rest of the triangle. Okay, so now I'm going to connect these 2 points together. And so what you have found, or what you have created, is a right triangle, because you can't count the units from A to B, right? So we don't know that. But what I can do is I can find the length of this segment here, right? Because if this is 2 units, because it's up 2, right? And then I go down to B. So if I count my units, 1, 2, 3, I'm sorry, 1, 2, 3, 4. It'd be easier on a coordinate grid, but we don't have one. Okay. Then I can identify the length of this line segment and the length of this line segment, and then I just have to apply my Pythagorean theorem to find the length of AB. So step 3 is to label your distances between the points for the legs. So we know that this point A, right, we know that that was at -5, +2. And we know that point B, this point right here, was at -2, -2. So if A, now I'm looking at my distance on this line here, so that means A is 4, or this line segment here, this is 4 units, right? Because I have half units here, so it's like I went down 1, 2, 3, 4 units. Okay, so that length is A, or 4. So now I want to count how many units is the length of this line segment. So I have 1, 2, 3, right? 1, 2, 3. So this length is 3. So now I need to find my hypotenuse, C. So step number 4 is to use the Pythagorean theorem to find the length from A to B. So we know we're finding the hypotenuse. Okay, so let's remember, right? So I know that this is C, so it doesn't matter if I call this A or B. So our Pythagorean theorem was A squared plus B squared equals C squared. And I know that my length for A is 4, and I know my length for B is 3. So I have 4 squared plus 3 squared equals c squared. I'm going to continue that over here. So 4 squared is 16. So 16 plus 9 equals c squared. And so now 16 plus 9 is 25. So 25 equals c squared. I can take the square root, and c is equal to 5. So the length or the distance between A and B is 5 units. Okay, so even if they're not labeled A and B, even if they're labeled C and D or E and F, you still do the same thing, okay? You still make a right triangle, count the units for your legs, and then find your hypotenuse. So let's try on the same coordinate plane. Let's put a point at 1, -6. 1, -6. So I'm going to go 1, -6, 2, 4, 6. I'm going to call that point C. And that was 1, -6. And then I'm going to go over 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6. So over 6 and up 6, 2, 4, 6. And I'm going to call that D. And that's at 0.66. Okay? So now I'm going to find the distance between D and C. And so I'm going to draw my line connecting D to C. That was step 1, right? Even though it says points A and B, we're going to connect the points between C and D. So now I want to make a right triangle. So that means I need to draw a line from D down, straight down, until it's in line with C. Okay, so go down to here. And then I want to connect this part of my triangle. Okay. So now I have a right triangle. So here's my right angle. And across from my right angle is my hypotenuse, right, which is C. So now I can use my Pythagorean theorem to find the length between points C and D on this coordinate plane. So now I can just count how many units long is this leg. So I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the length here is 12 units. I'm going to call that A. And this length here is 1, 2, 3, 4, 5. So this length is 5 units. I'm going to call that B. Okay, so now I'm going to do my work over here. So now I have A squared plus B squared equals C squared. This is not going to be easy. So A squared plus B squared equals C squared. So A is 12, so 12 squared plus 5 squared equals C squared. So 12 squared is 144, plus 5 squared is 25, and that equals C squared. So 144 plus 25 is 169 equals C squared. And now I can take the square root. And I believe that's 13. Yep. So my length between C and D, or the distance between C and D, is 13 units. Okay, so you just create a right triangle between the 2 points. You count the lengths for the legs because these are straight lines, right? We can't count the length here because it goes through half boxes, quarter boxes, it's diagonal. But since these are horizontal and vertical, I can identify my lengths here because they go by units. And then I apply my Pythagorean theorem. All right, so let's now look at word problems. So Pythagorean word problems. So whenever you're asked to find the distance in a word problem, you need to use Pythagorean theorem. So use Pythagorean theorem to find the distance in word problems. Okay. So let's look at example 1. The bases on a baseball diamond are 90 feet apart. How far is it from first base to third base? Okay. So a baseball diamond. The first thing that I would do with a word problem is draw a picture. So remember, you're not to make fun of me. I mean, that's not tragic, right? Okay. And so a diamond is like a square, it can be like a square, just turned, right? So all of these are 90 degrees. All of these angles here are 90 degrees in a diamond. And what we're told is that the bases are all 90 feet apart. So this is your home plate. This is first, second, and third base. So between home and first is 90. First and second is 90, 90, and 90 feet. Okay, these are all in feet. So the question is asking us, how far is it from first to third? So if I go from first to third base, how far is that distance? So if you look at either the top or the bottom part of that diamond, right, do you see that this is a 90-degree angle here? And if I turn it, right, so it looks more like what we've been working with. Okay, this side or this distance here is across from your right angle. We went through these right angles, so these right here are no longer 90-degree angles. They're 45, okay? So what we're looking for is C. Okay, So I'm looking for my hypotenuse. So I have an A and I have a B. So step 2 is use Pythagorean, label your parts of the right triangle as A, B, and C. Always identify C, and then A and B don't matter. And then use your Pythagorean theorem. To find the missing length. Or distance, whatever it's asking for. So I have A squared plus B squared equals C squared. So A and B are both 90, right? Because you're told that this is 90 feet and this is 90 feet. So 90 squared plus 90 squared equals C squared. So 90 squared is 8,100. So 8,100 plus 8,100 is equal to C squared. So I get 16,200 equals C squared. Then I can take the square root and we're going to round to the nearest tenth. So I have 127.279 equals C. So if I'm rounding to the nearest tenth, that means I'm rounding this place. This 7 is above 5, so I'm going to round this 2 up to a 3. So it's 127.3 feet from first base to third base. So you can say it is. So you always want to answer word problems in a sentence. Okay? So draw a diagram, figure out the part of the triangle that you're missing, and then use Pythagorean theorem. All right, let's look at example 2. All right, Kylie has let out 45 meters of kite string. I'll say of string. I don't like how they say kite string. Of string for her kite. Her kite is directly above a tree 20 meters away. How high is her kite? Okay. So, first thing I'm going to do is draw a diagram. So I have a tree. Here's my tree. I have Kylie. Here's Kylie with her ponytail. And she's happy because she's flying a kite. Oh, I didn't leave enough room there. So she's flying her kite right above the tree. Here's her kite. So she's flying her kite It's directly above the tree. And she is 20 meters away from the tree. So the question is, how high is her kite flying? We also know that she let out 45 meters of string. So this length here, here's the string for her kite, that's 45 meters. Hopefully you noticed that this is your 90-degree angle. And across from that 90-degree angle is your hypotenuse. So this is C. That means this is either A or B. And so we're looking for a leg. Okay? So I have A squared plus B squared equals C squared. I don't know A, so I'm going to leave it as A. A squared plus 20 squared equals 45 squared. So A squared plus 400, 20 times 20 is 400, equals, I don't know, 45 squared, 2025. So now I need to subtract the 400 because it's like an equation, right? And A squared's on the other side. So I have A squared equals 2025 minus 400 is 1625. And then I can take the square root of that, which is 40.311. So if I'm rounding to the nearest tenth, here's your tenths place. That 1 is lower than 5, so that stays at a 3. So Kylie's kite is 40.3 meters high. Okay? So I have 2 more examples for you. So if you want to try them and see how you do, great. If you need me to walk you through a couple more, I'm going to walk you through 2 more examples. And then there'll be plenty of examples in your practice. All right, so example 3. Jamie's house is 50 yards away. Directly across the street from Mike's. Okay. Teddy's house is next to Mike's house. And it is 56 yards away from Jamie. How far is it from Mike's to Teddy's? All right, so this is why drawing a diagram is super important because it sounds really confusing. So Jamie's house is 50 yards away, directly across the street from Mike's. So we have a house here. Let's call this house Mike. And then 50 yards away, directly across the street, is Jamie's house. Teddy's house is next to Mike's house. So Teddy's house is next to Mike's house and is 56 yards away from Jamie's. So from Teddy's to Jamie's house, it is 56 yards. So this one was 50 yards. Okay. So how far is it from Mike to Teddy's house? So this is the distance we're looking for here. So let's figure out what part of the triangle you're looking for. So here's your right angle. Across from that right angle is your hypotenuse, which is C. So that means I'm looking for either A or B. And since we found A last time, we'll find B. So now I have A squared plus B squared equals C squared. So A is 50 yards, so 50 squared plus B squared equals 56 squared. So 50 squared is 2,500 plus B squared equals 56 squared is 3,136. Okay, so now I solve for B. So I subtract my 2,500, and I have B squared is equal to 636. So then I can take the square root, and I get 25.219 is equal to B. So if I round to the nearest tenth, this is your tenths place. Right next to it is a 1, so I leave it at 2. So it is 25.2 meters, or sorry, not it. Mike's house is 25.2 meters away from Teddy's, sorry. Oof. House. And that makes sense, right? So because our longest side needs to be my hypotenuse, and so 25.2 is smaller than 56. All right, last example. Example 4. So 2 jets left the airport at the same time. I'm going to shorten it. Leave at the same time. Okay. One jet flew west at 250 miles per hour, and the other flew north at 300. 300 miles per hour. After 1 hour, how far apart were the 2 jets? Okay. So let's draw a diagram. So let's say here's our airport. So one jet flies west at 250 miles an hour. So here's your airport. Let's assume north is up, so west. Okay, so here's your first jet. And the other one flew north at 300 miles per hour. So north. Okay. How far apart after 1 hour? So after an hour, this airplane that flew west, or this jet, after an hour, it flew 250 miles. If it flies 250 miles in an hour, then after 1 hour, it went 250 miles. This jet flew north at 300 miles per hour. So after an hour, that jet flew 300 miles. So how far apart are they after an hour? We're looking for here. So here's your right angle. Across from that right angle is your hypotenuse. So we're looking for C. So I have A squared, so 250 squared. I'm going to call this A and this B. So 250 squared plus 300 squared equals C squared. So 250 squared is 62,500 plus, I believe that's 90,000. Yep, 90,000 equals C squared. Now I can just add them together. They're on the same side of the equal sign. So I get 152,500 equals C squared. Take the square root. And I get 390.51 equals C. So if I'm rounding to the nearest tenth, the 1 is lower than 5, so that 5 stays there. So after 1 hour, the two jets are 390.5 miles apart. So hopefully that makes sense after I showed you how to draw your diagram and set it all up. And then you can use your Pythagorean theorem to help you find the missing side of your right triangle. So there's plenty of practice problems for you to try. Make sure you do those and then check your answers, because the assignment that's on Edge Elastic is going to be an assessment grade. So I'm not going to help you on that. And neither is Miss Panza or Miss Staudinger, because that's an assessment. Okay? So the time for you to ask your questions is before you take it. And just in case you thought that you could have your friend do it first and then give you all the right answers, I've hidden the right answers. You won't know how you do until I post your grade. So this is due, your Edge Elastic is due by Wednesday. And it is word problems or finding distance on a coordinate plane for the Pythagorean theorem. So do the practice problems, and that is the time for you to ask clarifying questions. Okay? All right, guys, you know where to find me if you have any questions, and I will see you soon. Bye.